33. 33 gave us an interesting picture. It gave us two parallelograms, a little one, and then a bigger one. And they named one LENS, and they also then LENGTH. Did you notice that that's length? Okay, so what they've given you are two parallelograms. So now, because you're given parallelograms, can you use all those properties? Yes, no. So that means parallelogram LENS and parallelogram NGTH. The goal is to get this angle congruent to that angle up there. So can someone start with angle L and tell me what it's congruent to? Angle who? N? We can't use N because there's four angles. We can't jump from L to T. That's what we're going to prove. Because L is in this parallelogram, T is in that one. E, angle E, N, S. How do you know that? Because why? It's a parallelogram. What do you know about parallelograms? Opposite sides of parallelogram. Opposite angles of parallelogram congruent. Thank you, MJ. Opposite angles. All right. So L's congruent to this one. What can you tell me about angle T? It's going to be, thank you, congruent to which one? G and H. Why? Opposite angles of parallelogram are congruent. Okay? So now, anything special about these angles inside? So we know angle ENS is congruent to what? Angle G and H. Why? What did you say? Vertical angles are congruent. Now, this is what we're going to do next. Do you see your E and S? What does it equal? L. So what are we going to do? We're going to remove E and S, and we're going to put angle L in its place. What does G and H equal? T. So we're going to remove this angle and put what in its place? What did we just do? What's that called? Substitution. All right, next question. (26) 26. Because these two are congruent to each other and they equal those, I substituted. Does that make sense? Okay, so this is 26, correct? Yes, yes? All right, so 26 said 2a plus 30, and you've got 4a minus 4. Based on your foldable, what equation can you write? They are equal to each other. What's the reason? Opposite angles of a parallelogram are equal. So if we subtract 2a and we were to add 4, we get 2a equals 34 or a equals 17. They just wanted the variables. What's the next question? 14. I really like those. All right, so let's look at 14. We'll draw a pretty big picture. They drew in the diagonals on 14, and what did we just write down on our foldable about the diagonals? The diagonals are not equal. They cut each other in half. So They told us that PT, did you ask for 14? Yeah. PT is 2x. They told you TR is y plus 4. They told you that QT is x. And they told you that TS is y. I'm sorry, that's plus 2. I'm sorry, what? Yeah. Okay, so this is number 14. What's one equation that can be written based on what you have on your foldable? Samantha? Okay, what are these on? What segments of the parallelogram? Are those diagonals? Okay, so which one do you have to use? Look at your foldable. What does it say about diagonals? What does bisect mean? To cut in half. So what does x plus 2 equal? That diagonal got cut in half. What's its other half? Okay, this piece right here got cut in half. Yes. So x plus 2 equals y. What's my other equation, Jeff? Equals y plus 4. All right, so now, we have two variables. If x plus 2 is y, then can you remove y and put x plus 2 in its place? Does that make sense? So you've got 2x is equal to x plus 2 plus 4, or 2x equals x plus 6. Now what do? Subtract the x, so you have x equals 6. So if x equals 6, what is y going to equal? X is 6. 6 plus 2, I put 6 in for x, and you get 8, exactly. And that's how 15 and 16 both go. Next question. Which one? 13. 13, they've given you proof, but this case it is what kind? Fill in the blank. All right, so we're going to mark these as we go to make it easier. I believe they've labeled this A, this is B, C, D, and this is E. So we've got A, B, C, D, and E. What did they give us? They told us that A, B, C, D is a what? Parallelogram. So now if we know it's a parallelogram, then that should tell us lots of stuff. If it's a parallelogram, why is AB parallel to CD? What told us that? Alternate interior angles tell me that certain angles are equal. I need parallel. And the only thing we've been given is a what? Parallelogram. What was the definition of a parallelogram? In fact, on your open up your foldable. Under parallelogram, you have 4 properties, add a 5th property. Both pairs of opposite sides are parallel. And I want you to put in parentheses, definition of parallelogram. So, why are these two sides parallel? What did we just say? Definition of parallelogram. That's number 2. Oh, that was A, yeah. So I didn't number my angles. They went 1, 2, 3, 4. All right, so now on step 3, why is angle 1 congruent to angle 4? And why is angle 2 congruent to angle 3? Parallel, parallel. Why are those congruent? They're not opposite. They're part of an opposite. What's that letter? Right. And the only reason why we can use alternate interior is because in the line above, what did we learn? Do we have parallel lines? Does 2 and 3 make a same z? So you say if lines parallel, what kind of angles are they? Alternate interior angles are what? Congruent. All right, number 4 is now stating that AB, why is AB congruent to DC? Why is that true? Why is this side congruent to this side? Why? What? Look at your foldable. What does it say? Opposite sides of a what? Parallelogram are congruent. Were we given parallelogram above? Okay. So now we've got 1 congruent to 4. We've got 2 congruent to 3. And we've got AB congruent to CD. There 5 says angle, side, angle. Is that correct? Now, what goes with angle, side, angle in the statement piece? Okay, A, B, E, So A, C, D, E, nice corresponding of vertices. Okay, why do we prove triangles congruent? What's true about congruent triangles? Corresponding parts of congruent triangles are what? Okay, are these corresponding parts? Are these the other 2 pairs of sides? Corresponding parts, congruent triangles, congruent. So now we just now stated that this segment's equal to this segment, and that segment's equal to that segment. So if this segment's cut in half and that segment's cut in half, how do we know they're cut in half? Their reason was definition of bisector. And I would say definition of segment bisector. So what should their statement be? Right, AC and BD bisect each other. So you see, these congruent triangles are amazing as far as getting us where we need to be in so many other ways. I would say there probably will be a fill-in-the-blank proof, at least. There may be a proof in what we're going to do today. All right, so I'm going to teach, and then I'll come back if we've got time. So what we're going to do today, do you see everything on your foldable? Okay, all those properties, not yet, in case I can do more questions. You will lay it on this desk on your way out if I don't get to them. More questions. Properties of parallelograms makes a big assumption, okay? Assumes you have a parallelogram, okay? You with me? If you know you have a parallelogram, there's lots of stuff that's true about it. Today we're going to do the backwards piece. You don't know it's a parallelogram. And so now you've got to figure out why it is. All right. And let's see, I've got notes here, and I think I did lots. So we're going to, ways to prove a quadrilateral is a parallelogram. So there's 1 way, 2 ways, 3 ways, 4 ways, 5 ways. There's our summary. All right. So we will So these are 6-3 notes. The first way to prove a quadrilateral is a parallelogram is if you know both pairs of opposite sides are parallel. Then the quadrilateral is a parallelogram. If both pairs of opposite sides of a quadrilateral are parallel. This you have to show. Then you can conclude. Can I pause it? Seriously? No, I can pause it. All right. So what do you know about angle A and angle B? They're same side interior. Angle A and angle B are what? Look at their measures. They're supplementary. Angle A, you're just kind of reading this angle B wrong. That's 100. Okay, better. Angle A and angle B are what? Supplementary. Anything else? So if angle A, let's just work with that. If angle A and angle B are supplementary, what does that tell you? Well, now wait a minute. What kind of angles are they? Same side interior. If same side interior angles are supplementary, which lines are parallel? A, which one? Okay, is DC marked with a highlighter? AD is parallel to BC, all right? Do you see how the U helps me figure out which sides are parallel? That's one of the most important things I can model for you today. Why? Because if same side interior angles supplementary, then what do we know about the lines? Lines are what? Parallel. That's working that one theorem backwards. So what we've just discovered, or what we've just shown, is that these are parallel. But what does this say? Does it say one pair? What does it say? Both pairs. Can you tell me something else? Okay, but I need both pairs of opposite sides what? Parallel. So is there another pair of angles I can use? The equals does not get me because they are not alternate interior, same side interior, alternate exterior, any of those. B and C are what? Angle B and angle C are supplementary again. Now I'm going to trace those with the highlighter. If angle B and angle C, just a minute, I put these on the wrong side. That arrow should be here, and that arrow should be there. Why should it be there? Because those are the parallel sides the green highlighting. All right, so if B and C are supplementary, what does that tell us? That tells us that, look, what sides are parallel? AB is parallel to CD. And again, that blue highlighter shows the parallel sides. Why? Because if same side interior angles supplementary, then lines parallel. Now, I've got this pair of lines parallel. Now, have I met this criteria? Have I met it? Do I have both pairs parallel? So now I could say that quad ABCD is a what? Parallelogram. Why? In this case, definition of parallelogram, because that's what the definition says. So you are going to be looking for, in this case, I'm giving same side, I can get all. Oh, wow. If you're taking a test, you need to leave and you're like 10 minutes late. Anybody else? Okay. If both pairs of opposite sides are congruent, okay? If both pairs of opposite sides are congruent, we're no longer parallel, we're what? Congruent. Then the quadrilateral is a parallelogram. We know this is 12, we know this is 12, we know that's 5, and we know that's 5. So, does that meet this criteria? Thank you. Yes? So this is number 2, to show that we have a parallelogram. So you're not told that this is a parallelogram, but you're shown that the opposite sides are equal, so you know this is a parallelogram. And what's the reason? The reason is up there, because if both pairs of opposite sides are congruent, then the quad is a parallelogram. These are the converses, these are the reverses of what you wrote earlier. Okay, what else do you think? What do you think the next one's going to be? What would it have to say, though, about angles? Look at what you wrote and reverse it. Earlier today, we already did consecutive angles. It's another angle one. All right. So now we're going to reverse the next one. It says, oh, well, wait a minute. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So now we're going to do both pairs of opposite angles. So we know that this is 110. We know this is 110. How do I get the measure of that angle right there? It's going to be 110. You can't, because you don't know that these are parallel. So you're going to do 110 plus 70 is what? 290. And then how many degrees are in a parallelogram? What's 360 take away 290? 70. So that's how we get 70. We cannot subtract from 180 because we're not told parallel. Now, what do we have? We have both pairs of what? Opposite angles what? Both pairs of opposite angles are congruent. Then the quadrilateral is a parallelogram. Number 3. Could I have gone off what we did earlier, and could I have done consecutive angle sub, consecutive angle subs, therefore it's a parallelogram? I could have. No, because you can only say 180 if it's parallel. Okay, in order to do that C, you have to have parallel lines. All right, number 4. If you know that both pairs of diagonals have bisected each other, so this is the converse of another one. then the quadrilateral is a parallelogram. So we see that that is congruent to that, that is congruent to that, that makes it a parallelogram. Now we've got one more, and it's not a converse of what you've already written. Okay. Number 5. This says, now we're dealing in only one pair of opposite sides. Just one pair. Everything's been both. All right. If one pair is both congruent and parallel, there's the parallel symbol, there's the congruent symbol, then we can conclude that the quadrilateral is a parallelogram. So if we look at this, we definitely have one pair of congruent sides. What do these two angles tell me? What do they tell me? That angle A and angle B are what? Angle A and angle B are supplementary, therefore what do we know? Which lines have to be parallel? The ones that are highlighted, so BC parallel to AD. Do I have one pair of congruent and parallel sides now? Therefore, that is a parallelogram. So I think they're going to give you diagrams that are marked, and you have to figure out which one of these 5 will allow you to say that you've got a parallelogram. So this is working backwards. Okay, so let's look. Here's a summary. It's online if you want it. Prove both pairs of opposite sides parallel. Prove both pairs of opposite sides congruent. Prove both pairs of opposite angles congruent. Prove the diagonals bisect each other. Prove one pair of opposite sides are congruent and parallel. Those are the 5 you just wrote down. So now, here we go. Are the quadrilaterals parallelograms? If so, give the theorem or definition that justifies. Those 5 things that you wrote down are the theorems or definition that justifies. So if you look at this one, you see that this side is congruent to this side's congruent to that side. Is that a parallelogram? But what's the reason? If opposite, and maybe we need to say if both pairs, that's important. If both pairs of opposite sides of quad are congruent, then what? Then quad is parallelogram. Let's look at our next one. What about this one? Is this a parallelogram? This one? Yes. Why? Both pairs of opposite angles are what? So if both pairs opposite angles are congruent, then quad, opposite angles of quad. Then quad is parallelogram. I got about 5 more minutes. Now we're going to look at this one. That is 3. That is 3. This is 5. And that is 5. Is that a parallelogram? Yes. Why? If diagonals of quad bisect each other, then what? Then quad is parallelogram. So it's everything you did yesterday backwards. What about this one? All right, I see one pair of parallel, and I see one pair of congruent. What's wrong with this picture? It has to be the same pair of opposite sides, and they are different. All right, this is no. Now, if this arrow had been there and that arrow had been there, would it have been a yes? Okay, so you see the difference between those? So some of your problems tonight are no's and some of them are yeses. Caitlin. It's textbook. I think most of chapter 6 is a textbook. Okay, so now let's see what we are. Oh, so now, is the quadrilateral formed by points quad a parallelogram? So, based on what you've just seen, and this is probably the most important part, you're going to be either using distance formula or slope, okay? You can use slope to show both pairs parallel. You with me? Both pairs of opposite sides parallel. Or you could use distance formula to show what? To show what? Both pairs of opposite sides congruent. So I'm going to choose to use slope. Slope is rise over what? So I'm at D. I'm going to go up 1, 2, 3, 4, 5. Positive. I'm going to go to the right one. That slope is 5. I'm going to do QU, and this slope, and QU slope is down 1, meaning negative. And then we've got 1, 2, 3, 4, 5, 6. So now I'm going to do the slope of AU. Slope of AU. This is going to be a rise of 1, 2, 3, 4, 5. That's up. And a run of 1 to the right. So are these parallel? Because the slopes are what? So now we're going to do the slope of DA. So I've gone down 1, and I've run 1, 2, 3, 4, 5, 6. What do we know about those? Those are equal slopes. So those lines are parallel. So I chose to do slopes. That is a parallelogram, and this is why. You could have done distance formula. All right? You're only doing what? One flap. Yes, this is for all of the rest of it. So it's your choice as to how you want to do this, if you do slope or if you do the other. Distance formula. Did